Okay. And we're back. Okay, so I want to look at an example of a problem where we're converting a solution of molar HCl to percent by mass. Okay. Do you guys remember doing this in chapter 4, kind of, sort of?
Yeah.
We were given the density of the solution is 1.185 grams per milliliter, and the molar mass of HCl is 36.458. Okay. So we want to know how to go from Daddy M to percent by mass, right? What's the first thing that we need to know to be able to solve this problem? Or what are some of the things we need to know?
The mass that you have of HCl.
Kind of, yeah. I'm thinking more in terms of what these units stand for, right? You guys remember when we were doing solution calculations, I said the first thing you always want to do is translate out of these types of units and translate into a unit that you can actually use for dimensional analysis, right? That's the hardest part of these problems, right? So what does molarity stand for?
Moles of solute per liters of solution.
So we have moles of HCl per liter of solution, right?
Mm-hmm.
What about percent by mass?
Mass of solute over mass of solution.
Mm-hmm. Does that make sense, guys? Everybody all right with me? Cool. So we want to go from moles of HCl on top to a mass of HCl on top, right? What piece of information do we need to do that?
Molar mass.
Molar mass. Does that make sense, guys?
I always just get thrown off by like where density goes in. I feel like that always messes me up.
Yes, totally. But this is why I think writing out the units completely is the most important part, right? And what I mean by completely is now we have HCl as being belonging to one of the variables and the solution belonging to the other, right? And knowing which one is which is not trivial in this example, right? The molar mass belongs to HCl, right? Is everybody comfortable with that? I think that one's pretty easy, right? But the density belongs to the solution, okay? And that's the part that's confusing. So when we talk about the density, this is grams of solution per milliliter of solution, okay? It's not the density of HCl by itself, it's the density of the solution, okay? So to go from liters of solution to mass of solution, we're going to need the density of the solution. Does that make sense, guys?
Yeah.
Questions?
Oh, okay, makes sense now.
How are we doing with this, guys?
Good.
Cool. All right, so we're starting off with 0.5 moles of HCl per 1 liter of solution, right? So which one do you want to convert first, the top or the bottom?
You can do density first.
You want to do the density first? So the density has units of milliliters, right?
Yeah. So you gotta convert it to liters.
So I need to convert liters to milliliters. Is everybody comfortable with that?
Yeah.
So for every 1 liter of solution, how many milliliters do I have?
1,000.
Mm-hmm. Yep, yep. Now what do I need to do? So now I have milliliters of solution on bottom, but what unit do I want on the bottom?
You wanna then convert the molar mass, so you're gonna put the molar mass on bottom.
You want
density at my
the
bad.
mass
So
of, yeah, you want the mass of the solution, right? So you want grams of solution on the bottom.
Right.
So then that means you're going to need milliliters of solution to be up top, right? And 1.185 grams of solution down here. You guys picking up what I'm laying down? Everybody still okay?
Yeah.
Cool. So now I have moles of HCl on top, right? So do I need the moles on top or bottom here?
On bottom.
On bottom, right? So for every 1 mole of HCl, I have 36.458 grams of HCl. Right, so now I have grams of HCl per gram of solution. How do I make that a percentage?
I feel really dumb right now.
Sorry, you guys, I don't have the chat box up. Yeah, we gotta multiply by 100. Does that make sense? Yeah? We get a percentage from something by multiplying by 100. Cool? You don't have to do this step here. If it's weird and you're uncomfortable with it, that's fine. But me being the lazy person that I am, I see 100 being multiplied on top and 1,000 being divided on bottom, and I'm thinking I can get rid of some zeros here, right?
Well, yeah, I'm still kind of confused by this step now. Because you're ending up in grams, right?
I'm ending up in grams of HCl per gram of solution.
Oh, okay.
Grams of HCl per gram of solution.
Okay, that makes sense.
So this, what we had here, would be the parts by mass, remember? We have to multiply by 100 to make it percent by mass. Okay?
It makes sense. I have to physically draw the lines through to see what cancels out, and then you see that grams of solution doesn't cancel out.
Yep.
So.
Yep. So 100 is going to cancel with 2 of these zeros here. So I have 0.5 times 36.458 divided by basically 11.85. What do you guys get?
got 0.0154. But then you have to times it by 100, sorry. So 1.54%.
That sounds reasonable to me. 1.54 you said?
Yeah.
Anybody else want to back them up?
I got that too.
Cool. Questions about that one, guys? Percents always have... No, percents don't always have 2 decimal places afterwards. The reason why we have 2 decimal places is because we have 1, 2, 3 sig figs here. So we have 1, 2, 3 sig figs here. Does that make sense, Harrison? Yeah. Other questions about what we did there? We're all right. Cool. Are you guys okay with me erasing? Cool.
Yes.
All right, so the next one that I want to talk about is going from a molality to solubility. Okay, so this was molality again is moles of solute per kilograms of solvent, and the solubility is grams of solute per 100 grams of H2O. Okay. So this is definitely a problem you guys are going to see on the exam. Not on a quiz, but definitely on the exam. So let's say I have a okay? So I have a solution that's 0.085 molal is how you say that, potassium nitrate at 50 degrees Celsius. We want to know, will this solution be saturated, unsaturated, or supersaturated? So this is merging these ideas of conversions and incorporating now the concept of solubility. So that graph that we were looking at, where we had the solubility as a function of temperature. So the first step to solving a problem like this is you need to get molality here into solubility, okay? Once you have it in solubility, then it's very easy to read where you are on that graph at 50 degrees Celsius, okay? Does that make sense, guys, in terms of what our goal is here?
Yeah.
Cool. So, I have 0.085 moles of potassium nitrate per 1 kilogram of H2O, right? So, if I have a kilogram of H2O, right, it's more than 100 grams of water on the bottom. You guys agree?
Mm-hmm.
Specifically, what is it?
It's 1,000.
It would be 1,000 grams, right? So we can rewrite this as moles of potassium nitrate per 1,000 grams of H2O, right? Everybody still okay with me?
Yeah.
Cool. But I don't want 1,000 grams on the bottom. I want 100, right? So what could I do to make this have 100 on the bottom instead of 1,000?
You can just divide the numerator and denominator by 100, or by 10.
You want to divide or multiply?
Multiply.
Does that make sense, guys? So if I multiply by 10 here, right, then that'll cancel out one of these zeros on the bottom. Now here's the tricky part. This is where it gets tricky. We're not actually dividing by this number at all, right? So this number is just hanging out here. We're not putting it in our calculator. Okay? Does that make sense, guys? Because we want it to remain in the unit. But we don't want it to be 1,000, we want it to be 100, right? So the way that we do that is by multiplying by 10 here. Everybody okay with me still?
Yeah.
Cool.
So you're gonna...
So now the last thing we need to do is get moles of potassium nitrate into grams of potassium nitrate, right? So for that we need the
molar mass.
Molar mass. So we've got potassium is 39.098 plus nitrogen 14.007 plus 3 times our oxygen.
I have a question about the conversion for solubility.
Yeah.
Just because I'm just confused why you would multiply it by 10. Because when I think about it logically, if I'm gonna have 100 grams of the solution instead of 1,000 grams, shouldn't I have let moles of the solute? So shouldn't I be dividing it?
No, because we're essentially looking at, instead of looking at the number of moles per liter, right, which is a bigger volume, we're looking at a smaller volume. Or instead of looking at it in terms of moles of solute per kilogram of solution, which is a bigger volume, right, we're looking at it in terms of 100 grams. So we're talking about 10 times less solute.
I got it now.
Right? So the number of moles should look 10 times bigger, relatively speaking. This is easily the most complicated, or it's not the most complicated. It's a relatively simple calculation, but it's very difficult to understand, right? So if you guys have questions about this, please let me know. Anybody got a molar mass for me?
I got 106.102. I don't know if I'm right, though. I did it on my phone calculator.
Anybody else want to back her up? It doesn't sound unreasonable to me, 106.
106.1.
What'd you get, Daisy? Sorry.
102?
0.102?
Mm-hmm.
Wait a minute. Sorry, guys. I want grams on top. Sorry about that.
I got 101, not 106.
Anybody else?
I'm just gonna do it right now. Is that 39.098?
Mm-hmm. Sorry, guys. My handwriting gets real bad when it gets small.
And then,
Yeah, I got 101 too.
Okay. Boop.
Oh, that was a 14, right?
Yes. Not 19.
Oh,
Yes,
yeah.
totally.
Right.
Sorry. Cool.
I put in 19 and got 106 too.
So, all we're doing now for the calculation, just a reminder, the 1,000 is not doing anything here, right? We're not putting that in the calculator. We're just doing 0.085 times 10 times 101.102. So what do you guys get for the solubility?
Yeah, 85.94 grams, or sorry, yeah, grams over 100 grams of H2O. Grams of potassium nitrate. Or 100 grams of,
So 86?
yeah.
Everybody else okay with that?
Yeah.
So then you have to look up the solubility of
Oh, yeah.
whatever.
Now, I'm going to see if they have a good table in the book, which they probably don't, but we can check. Oh, they do. Delightful. All right. It's tiny. So this is the potassium nitrate curve, right? So if we're at about 85 and about 50 degrees, we're like pretty close to the saturation point there. Is that better? There we go.
It looks like we're unsaturated, right?
I would say this is too close to call. So I wouldn't give you this on an exam because I would say that looking at where the temperature is 50 degrees, right? If
It'd be in between, which would be
this
like
is
80.
really close to being
Oh,
saturated.
yeah, my bad. Yeah.
So if you're looking at this line, right, which comes to 50 degrees right around here, and then comes to, oops, the
Yeah, it looks like
temperature.
it's saturated.
Yeah, that's really, really close. So that would be a hard one. I wouldn't give you that on the exam.
I mean, but wouldn't you then, like, if there was a problem like that, wouldn't you just know that it's saturated because it is so close? Like, or in a hypothetical question, then would you obviously make it either unsaturated
Yes.
or oversaturated?
Yeah, yeah.
Super saturated.
Yeah. So it kind of has to be. Oh, that's what's going on. It kind of has to be obvious because otherwise those graphs are kind of hard to read. You know, the one that I have on the slide I think is a lot easier to read than the one that we were just looking at. But still, it's difficult to get exact when you don't have like a straight edge. And since this stuff is going to be on a computer, I mean, I guess you can use like a piece of paper to like do one of those. But I think it's really difficult to get something to be exactly saturated, right? So more likely you'll see something that's unsaturated or supersaturated, right? Because that's easier to read. Does that make sense, guys? Did you understand what I was saying at all?
Yeah, that makes sense.
Okay, cool. So I can pretty much guarantee y'all if this is going to be on the test. It's going to be. Okay. It's also going to be part of the last lab you guys do. These kinds of calculations going between molality and solubility units, right? So that's why I want to make sure you guys are comfortable with these. Any other questions?